Thank you. Well, my name is Eddie Davidson. I am head of technology at Aegis Energy. At a really high level, that means I'm responsible for all of our operational control systems, how we actually deploy technology to site, and I'm going to talk a bit today about how that interfaces with the grid, but also some of the kind of wider electrical and control integration challenges that we have on our sites. I've been with Aegis for about 2 years. Before that, I was part of a different startup building hydrogen-powered uncrewed surface vessels called Aqua Ocean. And before that, I spent almost a decade in the Navy, mostly on operational and systems roles on board submarines, so Vanguard-class submarines, which the Royal Navy operates. So I'm not a deep transport expert. I find myself working in transport decarbonization, but ultimately I spent a lot of my career doing systems integration and systems engineering as a whole. So when you actually see what our sites look like and how they work, you'd appreciate that often they behave like systems. And at least that's how I think about them. So I've got a presentation of about 15, 20 minutes today. It's in three big sections. The first section is I'm just going to give you an introduction to Aegis Energy. The second part is a single slide. I'm going to deep dive a bit into some of the electrical considerations that we need to apply when developing our sites. And then the final section is really on the economics of charging. And then there'll be some space at the end for a brief Q&A. So I'm going to get straight into it and talk to you a bit about Aegis to start with. At Aegis Energy, we are accelerating the decarbonization of commercial transport. And the way we are doing that is by building the UK's first network of multi-energy hubs for commercial vehicles. So there's quite a bit to unpack there in that statement. If there's three things you need to remember about Aegis, the first is that we are multi-energy. So we think electrification is a really big part of commercial vehicle transition, but we also think there's also other fuels, in particular HVO, which is essentially biodiesel, biomethane, CNG, and potentially hydrogen in the future as well. So as an operator, we take the view that actually the future is multi-fuel, it's not single fuel. That's the first big thing to remember. The second thing to remember is that we're building a network. So we're going to talk a bit about some of our early sites in a minute. Our ambition is to build 30 sites by the end of this decade. And the final thing to remember about Aegis is that we are catered for the needs of commercial vehicles. So there's a lot of charge point operators out there that serve the B2C market, private vehicles, etc. That's a relatively mature market. We are building bespoke infrastructure for commercial vehicles, in particular electric HGVs, electric vans, and obviously HGVs powered by those other fuels as well. And our sites are really located, as you might not be surprised to hear, in some of the key intersections and logistics hubs, junctions, and transport nodes that supply that commercial vehicle fleet. You can actually see there on the right a bit of a heat map based on DFT data around where we see some of the heaviest vehicle traffic in the UK. In particular, we see that across the logistics Golden Triangle, mostly in England. That doesn't mean that we're not interested in electrifying other parts of the UK. We definitely are. But at least our view for our initial sites is that we really want to target some of the key corridors that move freight and goods around the country. Obviously, this infrastructure is pointless if it doesn't supply commercial fleets, which is really our specific target audience. So you are very unlikely to find an Aegis hub in the city centre of a major city next to a shopping centre. It's very unlikely to happen. You're much more likely to find our sites in junctions, business parks, industrial estates, etc., where we can get quick access onto the strategic rail network. I've talked about the fact that we want to build quite a vast network of sites. We need to start somewhere, and our ambition is to build 5 sites over the next couple of years. Quite a few of these are already in development. Some of these are already in the build process. So the ones that we've talked about publicly are Immingham, Sheffield, Dartford, Orby, and Warrington. So again, mapping back to the point I just made a second ago, if you could see that logistics Golden Triangle and where it falls in the UK, you're probably not surprised to see where these sites are actually located. I'm going to talk about the sites and what they look like in a second. Before I move on to that, I would just say that we have these 5 sites to start with, but we have quite a deep pipeline of sites. Grid is one of the key constraints that we need to factor into that: size of grid connection, timing of that, requirements for reinforcement, etc. So we are also quite dynamic about how we prioritize our sites. We have a much deeper pipeline that we don't talk about publicly. And then if we have a site that has real commercial interest and the grid conditions allow us to open it and accelerate it, then we will actually accelerate it ahead of other sites. So we're quite flexible in how we think about the network and how we deploy it. So this is what an Aegis hub actually looks like. This is obviously a render, but will be one of our very initial sites. This is based on our design for our Smithywood hub. That's in Sheffield. And there's a few components here that I can just break down for you a bit. So the first thing to recognize is actually our site is segregated into light commercial vehicles, so vans on the right there you can see, and trucks on the left. There's a number of reasons why we do that, mostly around security, safety, vehicle flow, pedestrian control, etc. So this is bespoke infrastructure for those types of vehicles. We have secure driving, ANPR cameras, security, perimeter fencing everywhere, which is really important for the needs of haulage fleets in particular, but also wider truck fleets. We have a mixture of HVO refueling and HCV charging, and we essentially do that across different bays, fish phone arrangements, so that actually there's easy in and out access for trucks, 45-degree angles, and this is mostly in line with the emerging standards on how we should actually be constructing and designing these sites. If anyone's interested, there's a BSI Flex standard that we adhere to, and many others in the industry do as well. To talk electrically a bit about this site, the key thing just to highlight is that these are quite heavy sites from a grid loading perspective. We are talking about multiple MVA just to start with, and often we're trying to future-proof our site to understand what it would look like to have kind of tens of MVAs. Final point I make from a fleet perspective, we are also running our own booking systems, our own booking platforms, so that when people turn up, again, going to the point around reliability, they've got a book slot, they know they're going to get maximum power from a charger at the time they need it, when they need it, so that it actually complies with driver brakes. So that's quite an important point for us in the round. In terms of what chargers we are using, we are working with Siemens. We're deploying their 400 kilowatt chargers initially to our sites, and we're doing that for vans as much as we're doing for trucks. So in case the audience is kind of not aware, broadly speaking, we're seeing charging speeds in trucks now hit 400-500 kilowatts is relatively standard. There's a wider conversation about megawatt charging system that maybe we want to get into if necessary. But our view, at least, is that 400 kilowatt today is the standard. We think that there's actually room to go above that in the future. And we're also deploying this for vans because we want to make sure that it is as fast as possible for those fleets as well. I'll talk about SLAs and those elements later on. So that kind of concludes the first intro section into Aegis. I'm going to talk now a bit about the grid. It's a bit of a deep dive slide. It's just a single slide, but I'm just going to talk you through all the components. Apologies, big wall of text, but let me just start on the left. I'm going to walk you through this. So as a CPO, there are a huge amount of factors that influence the way that we develop our hubs. Grid is one of them: planning, land availability, commercial conditions, ground investigations. There's a huge amount of factors that go into this. Purely in terms of the electrical component of it and the grid connection component of it, from our perspective, there's kind of three really big things that we need from DNOs. The first is close relationship with the network planners and the delivery teams that actually go and execute these grid connections. It makes a huge difference to us when we have communicative, responsive, engaged planners versus planning teams that evidently are quite busy and really struggle to deliver some of the support that we need as a client to be able to develop some of these sites. So that's really first important point. The second one is access to up-to-date and reliable data for early stage feasibility. Without going down a rabbit hole, we use the DNO's open data portals a lot. There's a huge amount of information there. For those that in the audience that have spent some time navigating through those open data portals, they will know that the reliability of the data is sometimes not great. It varies a lot by DNO. And actually, this is a huge challenge for us when we're doing early site feasibility, because we have to invest huge amounts of money to develop the maturity of a design on a site. And that can be a really critical point. The final one is policy. There are a huge amount of consultations out there at the moment. As Aegis, we've been responding to them. Other people in the industry have been supporting them as well. It's really critical for us that we identify charging hubs as priority infrastructure for decarbonisation. We recently replied to the Ofgem consultation on this. And to put it into perspective, obviously we are at a national level making decisions about what infrastructure we prioritise where and for what. Our kind of broader concern is that if charging hubs in particular are not prioritized ahead of other assets and other infrastructure, we will find ourselves unable to decarbonize the transport sector in the UK, which accounts for about 20 to 24% of UK emissions, depending on the factors and the measures that you take into that. So it is a really considerable amount, and haulage, as in heavy goods and trucks in particular, are a really significant percentage of those numbers as well. So that's the relationship between CPOs and DNOs. Very briefly, to talk about that central pillar there in blue, the electrical considerations, if you're thinking of doing this yourself. And some of these messages might be quite common to the audience, and happy to explore some of this in the QA as well. To state the obvious, the location suitability is critical, and getting something like 1 MVA to your site is very different to 10 MVA. The amount of investment that is required up front is significant, and we often find ourselves needing to do reinforcement, modification applications, etc., because the sheer size of our grid connections is quite large. You'll then need to go on and consider the connection voltage into your host DSO. And traditionally, this hasn't been a huge problem because most people just try and connect in at 11 kV or try and pull into the local distribution network. We spend a huge amount of our time figuring out if 11 kV is the right voltage connection, or if it's 33, if it's 66, if it's 132. We spend a lot of time thinking through that depending on your long-term strategy. So for people trying to do this themselves at depots, this is quite a technical and quite deep depth conversation that needs to happen. If you've got through those two bits, all right, you need to think about the future proofing on your site. So what is the amount of infrastructure that you want to land today? And what is the infrastructure that you want to future proof for in the future? Sounds straightforward. It won't be in a minute once we talk about the sheer sizes of some of these chargers. The next point I'd make is that there's no easy answer when it comes to chargers. The audience will probably be aware of all-in-one chargers versus hub and spoke. So that's the all-in-one is when you essentially have the power electronics and the dispensing capability within a single unit, physical unit, whereas a hub and spoke is when you have power cabinets and you've got dispensers, and then you essentially create cable runs in between them so you can do load balancing and feed those. To put that into context, if you're trying to develop charging at your hub or at your depot, you will come into quite significant space constraints about how you want to do that. And you will probably need to make choices around how you move your vehicles on site. We hear it very often from depot operators that this is a quite significant challenge. The next point is in your consideration list is BESS and where it belongs. In principle, BESS is great. For those that are listening in that work for DNOs or work for planning organizations, they will understand that in particular, fault level headroom is a real significant constraint across the network in some areas, and that doesn't always work. So land BESS where you can. Don't take it for granted that you will be able to do that. The final 2 points is about charging specs. What are the chargers that you want to land, and how are you keeping up with the trends in industry? What we've seen at Aegis over the last couple of years is that chargers, in particular CCS2, is progressing really fast. So 500 amp continuous at CCS2 is now the default. We're seeing OEMs, charger OEMs, really push that and go higher and higher and higher. And I know that there's a speech later on as part of the panel from a charger OEM as well, from Full Tempo. There's also a wider question whether the megawatt charging system, MCS, is the right fit and future spec for trucks. In Europe, that is becoming much more common. In the UK, we are not seeing as much of that. But again, there is an open debate in the industry whether MCS is the right direction of travel or not. And the final thing you need to consider in all of these big questions you need to ask yourself if you want to develop these things is, what are the trends in the voltage architecture of the vehicles that then affect what infrastructure you are landing on your site? And what I mean by that is there is a really serious risk that you massively oversize your infrastructure because you're trying to cope with peak currents that you'll never see because the voltage architecture on vehicles is going up. So that balance is very careful. You've got to spend a lot of time thinking about it. It's very easy to spend a lot of money on electrical kit that you may not use downstream. So that's the kind of all the electrical considerations if you want to do this yourself on your depot, on your hub, and at least how we're thinking about it. I'll move on to this final section, this section in orange here. If you've got through all of that and you're convinced that this is something you want to deploy, the next thing you need to think through is navigating the grid and the engagement with the grid. And to be frank, there are a huge amount of challenges when you're working through ENA milestones, especially when you couple them with planning and commercial milestones. That's something you need to take into account. the interdependencies of your connection. So again, are you applying into a connection? Does it require a modification application? Does it require outages? What else are those circuits feeding? There's a huge amount of considerations that you need to think about when it actually comes to project delivery. The next point I'd make is that infrastructure at scale is a lot more challenging than essentially delivering, say, sub 1 MVA to your site. And to make a very broad brush statement, and this depends a lot on your location, but in general, what we're finding across the country is that if you're trying to get a few hundred kVA or sub 1 MVA grid capacity, most of the time it's relatively straightforward, and most of the time there is capacity in the network. If you're trying to find 5 to 10 MVA, that's pretty challenging. If you're trying to find more than 15 to 20 MVA, it is extremely, extremely challenging, and we've never seen that kind of headroom around the site. The final one I'd make is, how do you balance those priorities and charging your fleet? There is a point around public charging versus depot charging, and how do some operators want to approach that? And I'll come on to some of the economics of that in a second. So there's a lot of content on this slide. I'm conscious it's quite deep, so I'm going to move on to the final section now. But to summarize this at a really high level, in terms of relationship with DNOs, transparency and data is critical. In terms of your electrical considerations, if you want to do this yourself, spend a lot of time thinking about what vehicles you're going to buy, how you're going to deploy them, and in particular, your operating patterns to make sure you don't under or oversize your electrical kit on site. And the final point is, never underestimate the amount of navigating that you're going to have to do through the different milestones with the DSOs to make sure that you can actually get your development and secure your connection on time. There is a point that operators should really think about, and we think about this all the time, in terms of the true cost of charging installation. If you have a look at this graph that's in the center here, you'll be able to see in the middle, you can see network charges and wholesale and industry costs. That is what people normally think about when they think about the cost of charging at their depots. They think about essentially the price of power. What they often don't put into that number or think about in detail is all of the project costs. And again, people are quite used to deploying small AC chargers, whether it's at home, whether it's in small depots. For those that work in infrastructure development here, they will understand that deploying a 33 kV substation with multiple downstream 11 kV RMUs, transformers, all the associated LV gear, and all the distribution cables that go for that, when you're trying to move 600 amps plus through a single cable to each charger, is pretty expensive. It's very different to deploying a 22 kilowatt AC charger. So this kind of big block of the project cost is often missed and is not really thought about in detail. So broadly, if you are trying to do this in depot, what we actually see is that there's a good balance between trying to do public charging for the faster, higher speed at places like our hubs, and also being supported by good quality depot charging that's reliable. There is also a need for fit-for-purpose charging for commercial vehicles in particular. There's a bit of a pastime at Aegis that we do. We go around the country trying to spot vans in bays that they don't quite fit in. These are some examples that we see across the country. To make a very obvious point, a lot of these networks are built for cars, and vans are different from cars. They have different needs. They have different shape and sizes and lengths. And one of the things that we're doing for our sites is ensuring that every single one of our van bays is long enough to take a long wheelbase Sprinter to make sure that we can fit the largest fans on our sites, and we can give them as much current as they can take onto their vehicle. So how do you actually make that large scale charging operationally viable for your fleet if you're a fleet and you're thinking about doing this? In terms of what you will probably need is charger SLAs. Talked about uptime. A lot of it's about actually delivering above 99% reliability, which is what we're committed to delivering, and putting in place all the SLAs that you need to be able to do that. Second thing you're really going to need is to fine tune that operational support. It might be that you can do it in-house. We're providing 24/7, 365 assistance with multiple lines behind that, and that's really critical. And the final one is purpose-built infrastructure. Again, not making the assumption that you can use B2C charging locations to be able to service commercial fleets. The final point I make is if you are operating a hub, there's a couple of models that we deploy. You can definitely use our hubs on pay-as-you-go. If you want that as a customer, we're committed to building public charging infrastructure for all commercial fleets. So it will always be open to them on a pay-as-you-go basis. There's also volume-based agreements and deals that give you certain benefits like discounted pricing that's locked in, volume commitments, monthly fees, etc. So there's a better way to balance that if that is something that fleets are looking for. So I ran through a huge amount of content. Thanks for listening to that. Whilst we've still got a few minutes, happy to take any questions.
Just I want to go on one of the points that you mentioned there. Obviously, a lot of fleet operators are weighing up, depot charging against public or shared hub charging. Where do you think these hubs can really complement depot charging, especially for operators who like lease premises, face grid constraints, or even run like long haul routes? Obviously, they can't have depots everywhere.
Yeah, that's right. I think it really depends. And my view on this in general is that the future is a really good combination of good depot charging with good hubs. I think hubs fit in where you need immediate access to motorways, where you need guaranteed high-speed charging. I'm talking 400 kilowatts and above, and you know that you will get it when you turn up. And it also suits, as the point that you've made, fleets that are looking at the costs of developing their own depots and lease the land, don't actually own the land. It's quite a tricky conversation with a landlord to say, hey, can I install this massive, multi-megawatt transformer substations on your land? Can we go through all the process of, some people are even struggling to install AC chargers in some areas, right, and run the cables for that. So let alone having a meaningful discussion about heavy electrical gear. So that's where it suits. But our view in general is that depots are 100% here to stay. They're an important part of this. And then the hubs can really complement people that can't do that or just need the really fast top-ups in the critical moments.
Yeah. Oh, perfect. Thank you. You also mentioned the MCS standard and why you don't think that necessarily it's fully developed there yet, or potentially may not be the right path. Do you want to elaborate on that a little bit more?
Yeah, this is just my personal view on this. The standard is pretty much there. We're seeing vehicles that are fitted with it. We're seeing plenty of I'm pretty sure most of the charger OEMs have rolled out MCS solutions. I think it has a huge role for very long distance routes. I grew up in continental Europe. Some of my closest friends growing up operated lorries. They used to drive from southern Spain to Germany all the time, multi-thousand kilometers, long range driving. Great use case for MCS. The average haul length in the UK is 113 miles. I think we need to not forget that the UK is quite a small place. A lot of our haulage doesn't move thousands of miles. It moves hundreds of miles at best, and often it's not as much as that either. So I think there is a role for MCS. Eddie's view is that it's small in the UK, and actually, if you've got 400, 500, 600 kilowatts CCS2 charging, it's pretty good. That'll get you most of the way there. You don't really need more.
And I guess with the size of the batteries that you're getting in EHGVs, you only need a small top up to get to your destination anyway, where, while you're offloading, you could do another charge anyway.
Yeah, that's exactly right. That's exactly right. And again, if you've got depot charging and you just need that en route top up, it's a perfect balance that you don't necessarily want to charge, and just not to heavy too much on the electrical component of this, but if you're an electrical engineer thinking about what you need to deliver 1500 amps to a vehicle, think about the upstream electrical infrastructure you need to do that. Think about the size of the breakers, the buzz bars, the transport. It's not just the charger. There's a huge amount of, and if you're not going to do what comes upstream, why are you doing MCS in the first place? Because you can't deliver 1500 amps. So why don't you just use CCS2?
Excellent. And also, you spoke about how you've secured sites around major freight routes, including, Dartford M25 location, which is near and dear to my heart because it's close to me. How important is it that charging infrastructure for commercial vehicles is placed around the way freight moves around the UK? You spoke about that. What did you call it? Triangle or diamond? I can't remember the exact term you used.
The logistics golden triangle.
Yes, that was it. So how important is that when it comes to the charging infrastructure that you select?
It's really, for us, it's really critical. It's a huge part of our selection criteria for sites. In general, in general, fleets will not want to go out of their way for more than about 5 or 6 minutes to get to a charging hub, and that's probably like the very top of where they're willing to go.
Mm,
Our sweet spot's about a minute or two from a motorway junction, because essentially that gives them, they're on the route anyway, they need to get on and off. But it's really critical. I think the idea that a truck, which is running on a very tight margin, tight timeline, will divert 15, 20
yeah.
minutes to go to a charger over there. I think it just doesn't work. If you were a fleet looking at that, you'd go, no, I'm not going to transition to electric because I won't do that.
And do you think that's the like major difference from your perspective on how different it is in terms of serving vans and HGVs compared with more conventional public car charging? Because a normal person may be like, oh, I'm going to Tesco anyway, so I might as well charge there. Whereas an HGV is like, I'm on a route. I
Yeah.
can't pip out to a city centre or anything like that.
Yeah, I think you're right. I think that's a component of it. Reliability is a huge component of this. We
Mm,
talk to customers who are talking about moving pharmaceutical goods, which are temperature controlled, which are either going to be a specific time, specific place in a hospital, in a clinic. You, you know, there's millions of pounds worth of good in the back of that truck. Turning
you,
up and saying, "Oh well, our charger's down today," or "Oh no, my cables were cut yesterday," or it just doesn't work because you're about to
yeah,
lose millions of pounds worth of goods. So um, the reliability component is really critical.
yeah. And that's sort of the core theme of today is all about reliability. I know the government has reliability standards on public chargers, but I guess it's even higher as a requirement in this sort of framing that we're looking at. Also, looking ahead, what does Aegis need for the wider energy and transport system, whether that's DNOs, planning authorities, policymakers, or fleet operators, to make this kind of commercial vehicle charging network scale effectively?
Yeah, a lot of it is about policy prioritization and clear direction. I referenced the Ofgem consultation that we've fed into. There's also a number of other bodies. I know the DESNIS has run consultations. I know the Department for Transport spending a lot of time thinking about this, tying in the importance of these hubs with not just energy policy in terms of how DNOs actually day to day prioritize the queue. And there's a whole separate rabbit hole that we won't go down around prioritizing the demand queue, as like we've done with the generation queue. I think that's a kind of whole separate topic for another time.
Mm,
But actually giving clear policy at the national level, also when it comes to planning, is absolutely critical, because what we are finding in general is that councils look at our developments and they say, this is fantastic. We know that we need this infrastructure, but it doesn't fit within these boxes that we've defined for these use cases for these parcels of land. And we spend a huge amount of time trying to convince LPAs and councils on the value and the importance of these hubs. They get it, but it doesn't
yeah.
fit within national framework and policy. And as a result, sometimes it's a struggle.
Yeah, planning seems to come up quite a lot. Unfortunately, it's one of the bane of the UK's existence in terms of, it's always based on, how a council feels. It's hard to work on that basis when it's sort of vibes based.
Yeah, it's in general, actually we have had good relationships with councils, and most councils do actually want to see this infrastructure come to their
Yeah.
to their areas. Um, I think the challenge is when you get into the detail of it and you try and cross-reference policy and you try to understand what these hubs actually are, and you look at transport assessments, so you deal with some of the uncertainty. That's where some of the struggle comes from. We've always found that actually all councils are very open to this infrastructure. It's in the detail of policy.
Yeah, fair enough. All right. Amazing idea. That is our time now. Thank you so much for joining us this morning, and thank you for that answering my
Yeah.
questions. I know they were a bit all over the place,
No,
but
no, at all. Thank you very much
no,
for having
I
me.
appreciate it.